Okay, best way to understand this is probably to have a crack at doing an example. So here we go, we're going to try and find the equation of the plane, which has 3 points in it. So we've got 3 points, A, B and C, and we're just trying to find out the equation of the plane that goes through those points. The stuff we talked about before required a point and a normal. So the first thing we're going to have to do is find a normal to this plane. So find a vector which is at right angles to the plane. And the way to do that is to do the cross product of two vectors that are in the plane, because you remember that the cross product of any two vectors is at right angles to both of them. So what we need to do is find two vectors that are in the plane. So let's do the vector AB, which will be B minus A, so 1 minus 0, 1 minus 1, and 0 minus negative 1. I'll give us the vector AB, and let's do the vector AC. You could do any pair of vectors, it doesn't matter. So the vector AC will be 1 minus 0, 2 minus 1, and 0 minus negative 1. Is that? Okay, so we now have two vectors which are in the plane, and if we do the cross product of these two vectors, so AB cross AC, then the resultant of this will be something which is at right angles to them both. So remember, we do the old IJK, AB is 1, 0, 1, C is 1, 1, 1. So what we've got for the I one, we're going to have 0 minus 1 is negative 1 in the I direction. For the J one, we're going to have 1 minus 1 is 0, which will be minus, but makes no difference with 0. And K is going to be 1 minus 0 is 1. Okay, so our normal vector is going to be negative 1, 0, 1. Okay, so we now have a normal vector, and we can take any point in the plane. So let P be any point in the plane. So let's just do point A, 0, 1, negative 1. So now we have a normal vector and a point P which is in the plane. So we can go and we can write the equation of the plane in three different forms. So the first form is the point and normal form, which just says that x minus the p vector dotted with n is equal to 0. So that's a perfectly legitimate form of the plane, which in this case would be x minus our point dotted with our normal, okay, equals 0. So anything for which x makes this statement true will be a point in the plane. The second one was effectively expanding this bracket out. So we'd end up with x dotted with negative 1, 0, 1 minus 0, 1, negative 1 dotted with negative 1, 0, 1 equals 0, which implies that x dotted with negative 1, 0, 1, and if we do the dot product of this thing here, we get 0 and another 0, and negative 1 times 1 is negative 1, so minus negative 1 is the same as plus 1, which normally you'd write as x dot negative 1, 0, 1 equals negative 1. Okay, so anything for which x is true in this sentence will be in the plane, and the third way of writing it is the normal approach, which we've still got written up here. So the three components of our normal, n1, n2 and n3, in this case are negative 1, 0 and 1, and they just go with the x's, the y's and the z's. So we end up with negative 1x plus 0y plus 1z equals negative 1. And that's the equation of a plane in the x, y, z space.